The directions say to evaluate the line integral where c is the given space curve. Let's take a look at example 1. Suppose we have the integral over c of x squared y ds. C is the curve given by the parametric equations x equals cosine t, y equals sine of t, and z equals t, where t is greater than or equal to 0 and less than or equal to pi over 2. Remember, when you do line integrals, it is all substitution all the time. And so what I want to do first is I want to figure out ds right here. Now, to figure out ds, we need to find dx dt, dy dt, and dz dt. Dx dt is negative sine t, dy dt is equal to cosine of t, and dz dt is equal to 1. And remember, ds is equal to the square root of, we have dx dt squared plus dy dt squared plus dz dt squared dt. And so, therefore, ds is the square root of negative sine of t quantity squared plus cosine of t quantity squared plus 1 dt. Now, remember, by the way, a negative squared is a positive, right? And so sine squared t plus cosine squared t is equal to 1. And so therefore ds is the square root of 2 dt. So the integral over c of x squared y ds is the integral from 0 to pi over 2 of. Now, x squared is cosine squared t. Y is equal to sine of t right here. And remember that ds is the square root of 2 dt. It's all substitution all the time. And so this is equal to negative square root of 2 over 3 cosine cubed t, evaluated from 0 to pi over 2. And so remember, cosine of pi over 2 is 0. Cosine of 0 is 1. And so the correct answer to example 1 is square root of 2 over 3. Example 2. Suppose we have the integral over c of x e to the yz ds. C is the line segment from 0, 0, 0 to 1, 2, 3. Now, first, we need to parameterize c. And the typical way we parameterize a line segment is as follows. xyz is equal to 1 minus t times 0, 0, 0 plus t times 1, 2, 3, where t is greater than or equal to 0 and less than or equal to 1. So we're right here. And so that tells me x is equal to t, y is equal to 2t, and z is equal to 3t. Okay? Now, ds, right, we can do that to the side here. So I'll come over here. ds is the square root of. Now, remember that dx dt is 1, and so that's 1 squared. dy dt is 2, so we're going to put 2 squared. And then dz dt is 3, and so we're going to put 3 squared. And we're going to put all that inside the radical dt. And so ds is the square root of 14 dt. And now I'm ready to make my substitution. So again, the integral over c of x e to the yz ds is equal to the integral from 0 to 1 of. Now, x is equal to t. So that's right here. Times e raised to the 2t times 3t. So remember, y is equal to 2t, z is equal to 3t. And so that's where I get that piece. ds is the square root of 1 squared plus 2 squared plus 3 squared dt. And so on the second line, simplifying a little more, we get square root of 14 times the integral from 0 to 1 of te to the 6t squared dt. So this is square root of 14 over 12 e to the 6t squared evaluated from 0 to 1. And so the integral over c of x e to the yz ds is square root of 14 over 12, pulling that out in front, times the quantity e to the 6th minus 1. And that's example 2. In example 3, we have the integral over c of x squared plus y squared plus z squared ds. So my curve is given by the parametric equations x equal t, y equals cosine 2t, and z equals sine of 2t, where t is greater than or equal to 0 and less than or equal to 2 pi. And so it's really helpful for us to be able to figure out what ds is. And to do that, we need to find the derivatives accordingly. So dx dt is equal to 1, dy dt is negative 2 sine 2t, and dz dt is equal to 2 cosine 2t. So ds is the square root of 1 squared plus 4 cosine squared of 2t plus 4 sine squared of 2t dt. And so ds is the square root of 1 plus 4 times the quantity cosine squared of 2t plus sine squared of 2t, and then this whole thing dt. And so that tells me ds is the square root of 5 dt. And so the integral over c of x squared plus y squared plus c squared ds is equal to the following. It's square root of 5 times the integral from 0 to 2 pi of. Now, x squared is equal to t squared, right? Or actually, let's double check that. If we go back, x is equal to t, right? And that's what's telling me x squared is equal to t squared. Y squared is cosine squared of 2t. Z squared is equal to sine squared of 2t. And then we're integrating this with respect to t. But remember that cosine squared of 2t plus sine squared of 2t is 1. And so this is square root of 5 times the integral from 0 to 2 pi of t squared plus 1 dt. So far, so good. It's all substitution all the time. And so this is square root of 5 times the quantity 1/3 t cubed plus t, evaluated from 0 to 2 pi. And so the correct answer for example 3 is square root of 5 times the quantity 8 pi cubed over 3 plus 2 pi. Let's take a look at example 4. Suppose we have the integral over c of ye to the z dz plus x natural log of x dy minus y dx. My curve is x equals e to the t, y equals 2t, and z equals natural log of t, where t is greater than or equal to 1 and less than or equal to 2. dx is e to the t dt. dy is 2 dt, and dz is 1 over t dt. This is all substitution, okay? So this is going to be the integral from 1 to 2 of. Now, remember, y is equal to 2t. E to the z is the same as e to the natural log of t, because remember, z is natural log of t. dz, right here, is 1 over t dt. So it's 1 over t here, and I save the dt for the end. Okay, so that's the first part. Plus x, here's x, that's e to the t. Natural log of x is natural log of e to the t. dy is 2 dt. Again, dt is saved for the end. Then I'm going to go minus y, which is 2t. dx is e to the t dt. So that's e to the t is right here, dt is over here. So it's very, very careful substitution. You have to be very comfortable with your substitution. If I were in a 402 class, there are two things that I would be reviewing a lot, and that's your U substitution from Calc 1, right? Doing integrals utilizing U substitution, and then I would absolutely be reviewing the definite integral. Okay, the definite integral is really important when you get to a class like Calculus 3. Now, this is equal to the integral from 1 to 2 of 2t plus 2t e to the t minus 2t e to the t. But remember, the 2t e to the t terms cancel, right? Because 2t e to the t minus 2t e to the t is 0. And so what we're left with is the integral from 1 to 2 of 2t dt. But that's t squared evaluated from 1 to 2. And so the correct answer here is 3. And that's going to do it for this video. And this is a video on line integrals where c is the given space curve. So my previous video, c was a given plane curve. And in this video, c was a given space curve. Okay, thank you.